Welcome to Design of Structure. In previous lecture, we have completed the previous chapter as singly reinforced concrete beam. We are going to start new chapter of doubly reinforced concrete beam. In this chapter, we are cover necessity of doubly reinforced concrete beam, stress diagram for doubly RC beam, diversion of important formulas, types of problems, difference between singly and doubly beam, analysis, design, and exercise. Why doubly beam is necessary? When the applied moment on the beam is more than the moment of resistance of beam, the structural design has three options: to increase the depth of beam, to use higher grade of concrete to improve moment of resistance, to provide reinforcement in the compression zone of beam to increase moment of resistance WRC beam. Now, what is WRC beam? When the applied moment on the beam is more than the moment resistance of single RC beam, the moment resistance of beam is increased by providing reinforcement in the compression zone. This type beam is called WRC beam. We know that the concrete is weak in tension and strong in compression. To make the concrete stronger in tension, we provide reinforcement. But sometimes concrete is more weaker than we assume. That time, or also in case of any heavy loading condition and superloading or superimpose of floors, the beam is behave like a weaker beam in tension. That's why we need to provide both sides of reinforcement as a main reinforcement rather than the supporting reinforcement. That that double side provided reinforcement beam is called doubly reinforced beam. Why and where the doubly reinforced beam is necessary? When it is not possible to increase the depth of beam due to architecture purpose. Second, to get the headway in the roof. Third one, when beam is subjected to reversal of stresses. For pre-stress precast beam, we are going to study is that the image is of doubly reinforced section. In this case, provide AST, upper ASC, same as singly reinforced singly reinforced beam, upper portion concrete, the section of singly reinforced plus auxiliary reinforced section to merge up, we get the doubly reinforced beam. Similar to singly reinforced beam section stress diagram, we also have doubly reinforced stress diagram in which B, we know that the width of beam, depth, effective depth D small d, capital D overall depth, D minus D dash, the new part, and the D dash. D dash is the upper side cover of the beam. The values strain diagram 0.87 F5 by ES plus 0.02 and the low upper end 0.0035 F2 ESC ESC is equal to 0.0035 1 minus d dash by HU. That's why we will get the ESE. Now singly balanced section and auxiliary balanced section. For both, we calculate separately 0.446 FCK, similar 0.446 FCK. Here center of gravity 0.42 XU and C1. Here it is not on center of gravity, it's some above from the center of gravity, almost at the where reinforcement are provided. It's called C2. D D dash is the cover. Z1 section modulus for 1, Z2. Here are the nomenclatures. Now for singly valence section, some equations and some definitions we are studying. C1 force of compression in concrete. C1 is equal to 0.36 FCKB into HC, also given in the IS 456 page number 98, 98, 96. T1 is equal to force of tension in steel. T1 is equal to 0.87 Fy into AST. Z1 is equal to Leon T minus 0.42 X. This is the simple talk about the nominal beam. Now we are going to talk about auxiliary beam or auxiliary section, which we have C2 force of compression in compression reinforcement. C2 is equal to FSC minus FCC into ASC. T2 is equal to force of tension and additional tension reinforcement. That's why T2 is equal to 0.87 Fy into AST2. It is similar to T1, but the term AST is changed. Z2 is equal to overall depth minus cover of upper side. Now derivation of simple formulas. Moment of resistance of doubly RC beam is equal to moment of singly balanced reinforced section plus moment of auxiliary section is equal to mu is equal to mu limit plus mu2, or mu2 is equal to mu minus mu limit. In some case we are mostly get mu and mu limit, but we have to find that mu2. That's why we create the second equation like mu2 is equal to mu minus mu limit. From figure above this one, we are take mu2 is equal to P2 into Z2. To multiply both equation, we get mu2 is equal to 0.87 Fy into AST2 into D minus D dash. Similarly, for compression, mu2 is equal to C2 into Z2. For that, mu2 is equal to FSC minus sorry FCC into ASC into D minus D dash. We have both the equation of mu2, which is comfortable. We can calculate mu by all two, but sometimes we also use the third equation of mu2 is equal to fsc into asc d minus d dash. Now from the equation of 6 and 7, mu2 and mu2, equation 6 and 7, we get AST2 is equal to FSC into ASC divided by 0.87 F1. This is the simplest example of find AST, which also given in IS 456 2000 page number 96 clause number G 1.2. Now it is necessary to find FSC and FCC. Sometimes FCC is very important and FSC is negligible, but it's worth. First step up to d dash by d is equal to 0.20, we get FCC is equal to 0.446 FCK. And the second portion for mild steel, FSC is equal to 0.87 Fy. Fy is equal to grade of steel. We get some values, but in case of 415, Fe 415 and Fe 500, FSC value is obtained from SP 16 page number 30 table number F. And that table is given here from Fi 415 and 500, D dash by D ratio 0.05, 0.10, 0.15, 0.20. We get the different value and the value is picked from that particular region. Like our D dash by D is equal to 0.50 and we use grade 500, then the value of FSC is equal to 395. Sometimes in case of we don't have any SP16, that case we can find alternatively FSC by this equation. This equation is given in IS 456 page number 96, but I prefer SP16 formula because it is very easy and time consuming. Epsilon SC is equal to 0.035 XU max minus D dash divided by XU max. The equation also given in IS 456. I already said that. For mild steel, FSC is equal to 0.87 Fi. This is the fix. But in case of Fe 415 and Fe 500, we can do some exercise. Let for a beam D is equal to 6000 mm and 600 mm and D dash is equal to 30. XU max is equal to 0.48 D. From that, we can take 288 mm. Now put this value into above equation, we get 0.0313. Now from IS 456 200 2000 page number 17 figure 24 3a, draw a line from strain 0.0313 parallel to straight line portion of the curve. Corresponding trace 0.87 Fy. From here we get some nearer value of FSC like 356.9 meter mm square. But this portion is bit difficult, so I prefer you to memorize this table or use SP16 at the exam time. This is the difference between singly and doubly beam, which I cover in next lecture.